Today we're going to look at section 7.3, which is trigonometric substitution. So we're going to look at the ways to make equations easier by using trig substitution. So in looking at our expressions that we're going to be evaluating today, if they include the square root of a squared minus x squared, where a is just some number, we're going to substitute a sine of x in for our x value. And anywhere we see a squared minus a squared sine squared of x, we're going to substitute in a squared cosine squared of x. If we see the square root of a squared plus x squared, we're going to substitute a tangent of x in for x. And anywhere we see a squared plus a squared tangent squared of x, we're going to substitute in a squared secant squared of x. And lastly, if we see the square root of x squared minus a squared, we're going to substitute in a secant of x in for x, and a squared secant squared of x minus a squared will be equal a squared tangent squared of x. Okay, so if I look at example 1, I'm asked to integrate the square root of 9 minus x squared divided by x squared dx. So the first thing I'm going to do is I'm going to rewrite this top in terms of squareds. So I'm going to have the square root of 9 is the same thing as 3 squared minus x squared, which means that my a is going to be equal to 3. And since I'm dealing now with a squared minus x squared, what am I going to substitute in for x? A sine of x. So if my a is 3, then my x is going to be 3 sine of x. And my dx, then my new dx, is going to be 3 cosine of x. So if I start with all of my substitutions, this is going to be the square root of 3 squared minus 3 squared sine squared of x, because that x is squared, and so we have my sine, divided by 3 squared sine squared of x, because again, that x is squared, and my dx is 3 cosine of x. Okay, so I now have the product a squared minus a squared sine squared. So I'm going to replace that with a squared cosine squared of x. And I'll simplify this 3 squared to be 9 sine squared of x times 3 cosine of x. So far, so good. Okay, well, the square root of 3 is 3. The square root of cosine squared is cosine. So I end up with the integral of 3 cosine of x over 9 sine squared of x times 3 cosine of x. If I then put this cosine over 1 and multiply my fractions, I get 9 cosine squared of x, because 3 times 3 is 9. Cosine times cosine is cosine squared, divided by 9 sine squared of x. Yes, so then we cancel out the 9s. And what do we know about cosine over sine? What is that equal to? That cotangent. Tangent is sine over cosine. So this is like cotangent squared. Okay, so if you have your integral sheet, there should be something on there about cotangent. Anything? Anything? No cotangent? There's no integral cotangent on your sheet? Sine. So the integral of cotangent is the natural log of sine. So since this is cotangent squared, the natural log of sine squared plus c. Okay. If we look at example 3, we're asked to find the integral of 1 over x squared times the square root of x squared plus 4. If I rewrite the square root to be the square root of x squared plus 2 squared, because 4 is 2 squared, come in. Then that tells me that a is equal to 2. Since I have x squared plus a squared, what am I going to use for my x? Tangent, so a times tangent, so 2 times tangent of x. And what's your derivative of tangent of x? Derivative of tangent is secant squared of x. Okay, so if I replace all my things in my integral, I still have the 1 on top. X is now 2 tangent, so this is 2 squared tangent squared of x. X again is now 2 tangent, so 2 squared tangent squared of x plus the 2 squared stays the same. And dx is now 2 secant squared of x. What can we replace what's inside my square root with? If I have like a squared tangent squared plus a squared, what is that replaced with?
A squared.
A squared secant squared. Okay. So this would still be 2 squared tangent squared of x. And the square root gets replaced with a squared, which is 2 squared secant squared. And I still have 2 secant squared of x outside. So if I start simplifying, 2 squared is 4. So 4 tangent squared of x. The square root of 2 is 2. The square root of secant squared is secant. And I still have 2 secant squared x on top. And I'm going to make that be into a fraction, so it's over 1. So we can start cross-canceling. Okay, so I'm going to cross-cancel this 2, and this secant cross-cancels with the squared part of that secant. So if I multiply across, I get secant of x divided by 4 tangent squared of x dx. Okay, I'm going to pull the 4 out front. So this is 1/4 times the integral. Secant is 1 over cosine of x. And since I'm going to multiply by what I'm dividing by the reciprocal what I'm dividing by. So since tangent is sine over cosine, in this case I'm going to multiply by cosine over sine squared, because my tangent is squared. And then one of my cosines is going to cancel. Yep. Okay, well, cosine, I can let be my du because I can let sine be my u. So if I do u substitution where u is my sine, then my derivative of u is cosine. Everybody agrees with that? So I would get 1/4 times the integral 1 over u squared du. And what's my integral of, well, this is like u to the negative 2. What would be my integral of u to the negative 2? U to the negative 1 over negative 1, right? Because I just add 1 and divide by that plus 1. So I get u to the negative 1 over negative 1. I still have my 1/4 out front. And so if I simplify that, I get negative 1/4 negative 1 over 4u. So I move that u to the bottom. And u, in this case, was sine. So negative 1/4 sine of x. Okay, let's do one more. Okay, so I have x over the square root of x squared plus 4. Again, I'm going to rewrite this square root as x squared plus 2 squared. Therefore, letting my a be 2. What would then my x become if I'm dealing with a squared, or x squared plus a squared? Okay, a secant, so 2 times secant of x. Anybody remember the derivative of secant of x? I don't think so. The derivative of secant is secant tangent. So this would be 2 secant tangent because of the 2 secant. Okay, so if I start replacing things, my x becomes 2 secant of x. Down below, I have x squared, so 2 squared secant squared of x plus 2 squared of x. And my dx becomes 2 secant of x tangent of x. What can I replace what's inside my square root with? Well, that's like a squared secant squared of x plus a squared. What did we say that we can replace that with? Maybe this is supposed to be a minus. We'll make it a minus. Then you can replace it with a squared tangent squared. I probably just problem, so I guess. So 2 squared, tangent squared. Square root of 2 squared is 2. Square root of tangent squared is tangent. So then we can start cross-canceling things if I make this a fraction. So 2 cross-cancels with 2, tangent cross-cancels with tangent, and I get the integral of 2 secant squared of x dx. If I pull the 2 out front, because you can pull constants out front, I get 2 times the integral of secant squared of x dx. And that should be on your integral sheet. The integral of secant squared, I believe, is there. Tangent of x, right? So, since the integral of secant squared is tangent, this just becomes 2 tangent of x plus c. Okay, so the steps are that you have to figure out which expression you're dealing with of those 3 expressions, and then to substitute in the pieces that match to make it as simple as possible. So you guys are going to work through page 507, 4 through 16.